So our next step, we've done that worksheet where we did the area. Remember, we did the area of a triangle as A times B times the sine of side C, or of angle C over 2. Remember that one. And we did the area of a polygon. This is the area of a triangle. Of a polygon is the number of sides times the length of a side squared. I think we used S squared instead of L squared, but over 4 times the tangent of 180 over n. That formula look familiar? Today we're going to learn a new formula. If I have points on a graph, you don't necessarily need to be able to graph to do this. I'm going to start out with a triangle here. This point here is 1, 2. This point here is 11, 2. And this point up here is 1, 11. What is this dimension right here? What coordinates do I subtract to get that?
11 and 1.
Yeah, the x coordinates, the 11 and the 1, that's 10. What's this dimension right here? 9. The 11 and the 2, right? The y coordinates. So that area should be 9 times 10 divided by 2, otherwise known as 45. And I'll put units squared here, because I don't know what units that grid is marked out in. If it's marked out in inches, feet, rods, yards, whatever, right? But if I have a grid like this, I can pick a starting point. So my starting point I'm going to pick here, I'm going to pick the 1, 2. Then I'm going to go around counterclockwise. So going counterclockwise, what's the next point? The 11, 2. So I'm going to list that. Now the next point, 111. Have I gone completely around the figure yet?
No.
No, I have to go back to where I started, which would put me back at 1, 2. So what I've done is I've what they call circumnavigated the figure. I've gone all the way around it. The point I started at must be the point I finished at. So that point, yes, that point will be listed twice. The first point will also be listed as the last point. So we talked about matrices a little bit last semester with systems of equations. Talked about determinants. We didn't get into a lot of it with determinants. So we talked about down diagonal products and up diagonal products. Well, here we're going to do down diagonals going this way. What's 1 times 2? 2. What's 11 times 11? 121. What's 1 times 2? 2. That adds up to 125. Now we're going to do diagonal products the other way. These would be the up products, but we're going to go right to left so that they end up on the other side here. So I'm going to go 2 times 11, 22. 2 times 1, 2, and 11 times 1, 11. Those add up to 35, right? So now I'm going to take this one, the 125, minus this one, the 35. Gives me what? 90. And the final step is I'm going to divide that by 2 to get 45 units squared. Guess what? That's the same area we had before. So this process gives us the area of that figure from its coordinates. Doesn't have to be a triangle. I used a triangle here because I could do a triangle's area. I knew I could find a formula for the triangle's area. Doesn't have to be a triangle. Any shape, yep. Anything that I had that has straight line sides and coordinates for. So let's do this. Let's take okay, so let's say there's a point here at 4, 3. A point up here at 7, 9. A point over here at negative 6, 4. A point here at negative 9, negative 5. A point here at negative 1, negative 9. A point here at 8, negative 4. And then back to the starting point. Kind of an ugly looking shape, isn't it? Any idea how we would find the area conventionally? It would be rough, right? Let's pick a starting point. We'll pick the 4, 3. What's going to get listed next? 7, 9. And then negative 6, 4. And then negative 9, negative 5. And then not everybody at once. Negative 1, negative 9. And then 8, negative 4. And then back to the beginning, 4, 3. So, down products. 4 times 9. 36. 7 times 4. Right. Negative 6 times negative 5. 30. Negative 9 times negative 9. 81. Negative 1 times negative 4. 4 and 8 times 3. 24. So we got there, what? 28, 109, 139, 167, 203 it looks like. So let's do our products the other direction. So going this way. 3 times 7. 21. 9 times negative 6. Negative 54. 4 times negative 9. Negative 36. Negative 5 times negative 1. 5. Negative 9 times 8. Negative 72. And negative 4 times 4. Negative 16. So we've got what? Negative 90. Positive 10, so negative 80. Looks like we've got a negative 152 there. Is that what you guys get? So now what are we going to do next? 203 subtracted negative 152, which is going to be 355. And then divided by 2. So 177.5 units squared. What do you think? Why would this be useful for you guys?
Well, if we have odd shapes, we can just plot points.
Let's say you're doing a survey of a plot. And now these coordinates are going to be given in rods away from a reference over here. So that there's survey stakes, there's permanent survey stakes all over the place. You ever run into them, the big metal stakes that are in the ground that have the big head on them? Those are permanent survey stakes. Usually it is illegal to pull one of those out of the ground. Don't ever do it. If you find one, don't do it. So let's say that this isn't going to be in rods again. So let's say that this corner here of the property is at 32,9 rods from that stake. 16.5 feet. 16.5. What's that? Okay. Oh, sure. And let's say they go here. Oh, let's say that is 82,13. Here is 82,41. This is going to be 27, 29, and back to there. And most surveying now is actually done. They don't do a whole lot of using the surveyor's wheel and rolling it out on the ground. Partly because there was a lot of inaccuracy there, because surveying is done on the level. So like if you have a steep hill, it's not the surface of the hill. It's like if here's your hill, the survey distance is actually this distance, not the slope of the hill. So if you have a really steep hill, you actually have more land surface than you do. Surveying is a flat dimension. An acre is a flat dimension. So you may have more land surface because it's on the side of a hill, but the acre is seen from above. So using that surveying wheel, you had to correct for slopes in the land and stuff like that when you were doing it. So there was some estimation in cases of what your correction factor was. So yeah, they use a very finely tuned GPS. That GPS now can be within inches of your coordinates. So you use the GPS to find those coordinates. So now, pick a starting point. 8241. Okay, what would be next? 2729. What would be next? 32.9. And next? 8213. And next? And then 8241. Back to the start. Now what? 82 times 29 gives us 2378. And then 27 times 9 gives us, what's that? 243. Yes, you're correct. And then 32 times 13, which is, and then 82 times 41, 3362. Then add them up. You are correct, 63.99. And then 41 times 27, which is, what's that? 1107. And then 29 times 32, which is, what's that? And then 9 times 82, which is 738. And then 13 times 82, which is 1066. And then 3839. Very good. And then 2560. And then divided by 2. 1280. That's going to be square rods. 1280 square rods, by the way. How many acres is that? Okay, remember 1 acre. 43,560 square feet. If I want to convert that into square rods, it's going to be, put that over 1 times. 1 square rod is how many square feet? Well, 16.5 feet in a rod, so you square it, you get 272.25. $43,560, yeah. I just wrote it real sloppy. Square feet cancel out, so you take 43,560 divided by 272.25. 160. So 160 square rods in 1 acre. So I've got 1,280 square rods. I divide by 160 to get me 8 acres. That's pretty convenient. I could not have made that come out to an exact acreage again if I tried.
And you divided 160 from
1280 divided by 160. There's 160 square rods in an acre. Any questions? So what if I just list the points for you? They have to be listed in order. These would have to be listed in counterclockwise order.
So if you didn't list the order, you couldn't do anything.
You'd be screwed, yes.
Well, unless we actually had grid drawn on, but
Not necessarily.
not really, huh?
There are some of them where it'd be tough to figure out what order they went in. So I have to tell you, these are in counterclockwise order. So how would we figure out the area of this?
Line them versus
Okay, what am I going to start with? 3, 7, okay, and then what?
511,
And then?
-2 and 10,
-2, 10, and then?
-5, -1,
And then?
7,
And then? Oh, good catch. A lot of groups forget to put that first point back there when we get to this point.
Yeah.
So you can pat yourself on the back. Don't hurt yourself. And then? What do we do next?
3 times 11,
3 times 11 is 33, and then?
7 times
5 times 10, you mean?
5. Oh, yeah. Let's go with the opposite way.
Which is 50. And then? -2 times -1. And then? -5 times -2. 10. And then? 7 times 7 is 49. 144? And then? Come on, Tate. You were there.
Let's go down. Oh, 7 times 5.
7 times 5. Yes.
Now I can
I was
say
waiting for
11 times -2.
11 times -2 is -22. And then?
And
10 times negative 5 is a negative 50, and then
Negative 1 and 7.
negative 7, and then
Negative 2 times 3.
negative 2 times 3 is a negative 6.
And
Get negative 50. 144 minus a negative 50. 194, and then divide by 2. 97? 97 square units. Cool. Well, I've got two things for you today. One's going to be a new worksheet. The other one's going to be quiz. Yeah.
Oh, we're getting a double dose.
Does arithmetic really just cover the basis of all math? Or is that actually something?